Well, hello everyone. This is the first of two videos that I'll be making to replace the time that was lost during my illness. The first thing we're going to do is find the centroid of a region, like the centre of mass of a region, that's basically the area bounded by two curves. So can you imagine you start at x equals a, you finish at x equals b, you've got a curve up here called f of x, you've got another one directly below it called g of x. Then the centre of mass x bar can be found by calculating this guy. You know, if you cover this guy up, can you see x, f of x? And if you do the y bar, it's this guy. And if you cover this piece up, you see the half fx squared that we did when it was an area under a single curve. And a is the integral from a to b of f of x take away g of x. So the only thing that you really need to make sure is that f is the further up, the biggest, right? The top, and g will be the bottom. So there are only two questions. Question 9 involves a curve and a line. So pick my own version of that one. Suppose we have, so this is my version of question 9. Suppose we have y equals x squared, and we have x plus y equals 1, and we plug in a y equals 0. And by the way, y equals 0 is just another way of saying the x-axis. Well, I should be able to do the curve y equals x squared without referring to Desmos, but if I did, or I wasn't sure, I could certainly do it. X plus y equals 1 is actually just another version of 1 take away x if you rearrange it. So it's essentially a straight line, maybe not to scale, but starts here. And it goes something like that. So the region that we're trying to find the center of mass is this region here. Now you should be able to find these intersection points. Oh, feeling that there should be 2. Let's change it now before too much damage is done. So if I wanted to find these two guys, essentially what I would do is I'd find out when this curve meets up with that guy. So if you take x squared and you find out when is it equal to 2 take away x, you get x squared plus an x take away 2 equals 0. That's why I changed that to 2. And if you factor this guy, you're going to have a plus 2 and you're going to have a negative 1. So that pretty much tells me that this guy here is going to be negative 2. And I can do that because when you solve this, x is negative 2. And when you solve this guy, x is equal to 1. So I know that this guy here is going to be 1. So that's a good idea to draw a sketch on your TI-84 or Desmos if it was handy, and find out where the two curves intersect. And we are ready to rock and roll here. So what we're going to be looking at here is the centroid, the center of mass of this guy. God, it's hard to guess, isn't it? Especially in the fact that my scale isn't great. So I'm going to go for around about here. That would be my guess. I won't put any numbers in because my scale is so bad. There's a very good chance that I'm miles out. So we've got our shape. We have identified that y equals this straight line, which is y equals 2 minus x, is clearly the higher of the two. The curve is low down, the straight line is above it. So technically, I shouldn't be calling that f of x at all. Shouldn't be calling this g of x. And I should call this guy f of x. So the area is the integral from -2 to 1 of the straight line, which is what? 2 take away x, minus the quadratic x squared dx. So that's pretty much going to be the integral from -2 to 1 of 2 take away an x, take away an x squared dx. Getting my calculator. Hopefully I brought it home with me. So, power rule, power rule, power rule. Evaluated at -2 and at 1. So it's going to be 2 times 1 minus a half times 1 squared minus 1/3 times 1 cubed. Subtract 2 times -2 minus 1/2 -2 squared, -1/3 -2 cubed. Whoa, just about got that guy in. I could definitely do that whole horrible mess in the calculator, but I'm going to just take a little bit more time. 2, take away a half, take away a third, subtract -4. Well, if you do that and that, you're going to get 2 squared, you're going to get 2 and 2, that's going to be a -2. And this guy is going to be 2, 4, 6, 8, 8/3 and a positive. So at this point, I'll get my calculator out and we'll see what we get. And since it is a physical area under a curve, it better be positive. And if it's not, then I know I've made a mistake. So 2 take away 1/2, subtract 1/3. Okay, that's the first lot. Subtract, I'm going to see it in my calculator. 2 take away a half minus a 1/3. Subtract, put a bracket in. -4, subtract 2, add 8/3, and I get that. And if I hit the math button, option 1, I'll turn it into 9/2. And that is good. Well, that's one piece of the puzzle. There are a lot more pieces to get before we're finished. Now that I know this, we can then move on to getting x bar and then after that y bar. So x bar is 1 over a, the integral from a to b of 1/2 the highest function, f of x squared, which in our case is a straight line, take away the lower of the two functions, g of x squared dx. Now, since a is 9/2, you can see here, since a is 9/2, 1 over a, 1 over 9/2 is 2/9. So that takes care of that. It's going to be the integral from -2 to 1. It's going to be 1/2. The straight line, which is what 2 minus x, goes first and you square it. And the other guy, the curve, was the lower down one, and that's that guy when you square it. And you do dx. If I pull this half out, I now have 1/9. The integral from -2 to 1. I have 2 minus x squared, take away x to the 4. That's 1/9. The integral from -2 to 1. And let's square that guy. You get 4 minus 4x plus an x squared, take away x to the 4. Okay, I can do the power rule now. 4x, take away 2x squared, plus 1/3 x cubed, take away 1/5 x to the 5, and evaluate it at -2 and 1. And no one has noticed, but I thankfully did, because nobody's here to notice. I've actually written down the formula for y bar, but that's fine. I can find y bar, and then after that I can find x bar. So it's going to be 1/9, 4 times 1, take away 2 times 1 squared, plus 1/3, 1 cubed, take away 1/5, 1 to the 5. Then subtract. 4 times -2 is -8. -2 squared is 4, so you get -8. That's -8/3. And that's 2, 4, 8, 16, 32, also negative, so that becomes plus, so 32 fifths. And I had to do that so I could get enough room to put it. Right, at this point, I'll do a calculator. In brackets, 1/9, that way it's just safer, times, well, this guy is going to be in its own bracket, so times, so it's going to be 4, take away 2, add 1/3, take away 1/5, close that guy off, subtract, start another set of brackets for this guy, -8, -8, oops, almost made a mistake there, subtract 8, subtract 8/3, add 32 fifths, close that guy, close one more for luck, and then make this guy a fraction. And the answer is 8/5. So y bar is equal to 8/5. Okay, let's go back to my picture. Well, you know, that 8/5 is a little bit higher than that, but at least it's not miles off. Now, I have just done y bar, and it's okay to do them in, you know, y first and x bar second. So the last thing I'm going to do is find out what x bar is, and it is, as you can see here, equal to 1/a, the integral from a to b, x times the high function, take away the lower function, dx. And a, we already did a few moments ago, is this guy, 9/2. So 1/a is 2/9 again. It goes from -2 to 1. It goes x. The straight line is higher up. Take away the curve, which is lower down. And that's pretty much our integral setup. So distribute all that, you get a 2x, a take away x squared, take away an x cubed, dx. To the power rule, it's going to be an x squared, take away 1/3 x cubed, take away 1/4 x to the 4, evaluated at -2 and 1. So 1 squared is 1, that's take away 1/3, that's -1/4. Subtract. Plug in -2 here, you get 4. Plug in -2 here, you get -8, which combines with that to give you +8/3. And -2 in here eventually gets you +4, but there's a negative there, so there's a -4, and we're looking at that guy. And well, actually, I think I can do a little bit more. These two kill each other off, so all you're going to basically be doing is subtracting what's left, which is 8/3. Right, now I can do it on the calculator. In brackets, 2/9 times another bracket, 1 subtract 1/3, subtract 1/4, subtract 8/3, close the bracket, and the answer is, well, I can tell you that's -1/2, but let's just do it on the calculator. And so we are looking at x bar is -1/2. So I'm going to return to my picture. Let's put all the information together. The centre of mass, the centroid, has an x coordinate of -1/2 and a y coordinate of 8/5. And on my picture, -1/2 would probably be about here. And so roughly, it's a little bit higher and to the left of what I predicted. But all in all, a pretty good guess. And that basically is the entire process that you're going to be doing to calculate the area, the centroid or centre of mass of a region bounded by two curves. And as I say, there's two questions. Question 9 is very similar to the one I've done. And question 10, and the only thing you have to realise to do in question 10 is that you're going to have to rewrite x equals y cubed, because you've got two functions, x equals y cubed. And you're going to have to rewrite that in a format that's going to lend itself well. So if you put this, so this is essentially the question 10 information, set up the integral in terms of x and you'd find the area, right? So this guy can be rearranged as the cube root of x. Now, if you do x cubed, you've got this guy. And if you do the cube root of x, it kind of looks more like this guy. Now, they also tell you in question 10 that you're only interested in this piece. So the red one is clearly the highest, and the red one is going to be the cube root of x. So that guy is going to be f of x. And y equals x cubed is going to be your g of x. And you're going to be doing it from 0 to 1. And pretty much same method as we did in this earlier question. So I hope this has been some use to you. And goodbye for now. And I will be making another video that you'll see on hydrostatic pressure. So bye-bye.